words, cause and effect are no longer happening at the same time. In this situation, the cause comes first, the effect comes later. In this situation, and we can get away with this in alternating current, first we have the effect and then we have the cause, and this is called the hysteresis loop. This angle of hysteresis, okay, where this thing is actually a circle and it's rotating. These are distorted waves produced by real machines. But this idea that it would be a circle, if the circle turned sideways, it would be a straight line, there would be a direct proportionality between cause and effect. But as we start to take that circle and move it, like that plane on the cones, we start to get out of that dimensionality, okay, and it opens up into this ellipse. And then the ellipse keeps turning, and then it turns into a circle. And in that situation, cause and effect are non-related. At that point, they can't really be corresponding anymore, and they start to lose sight of each other. It's a very complicated thing to explain, but it's produced by this fact that the inductance and capacitance, like we showed earlier mathematically, when they vary with respect to time, then we end up with resistance and conductance, which means energy is either appearing or disappearing in the system from another system of dimensions, or it's being dimensionally taken apart. And these distorted waves then produce these energy imbalances because there's not the same amount here as there is here anymore. It's not balancing out. Now this requires another type of mathematics, more advanced symbolically, which we'll just briefly go over. But this is the way in which you synthesize energy, is you start with this method in an alternating current system. And this is how these power systems would take off on their own, is by developing these hysteresis cycles, these big arcs, changing their properties with those AC cycles, and causing the cycles to distort in these fashions, and then all of a sudden the energy balance goes off in some way where the energy is basically being built out of pieces, out of time and space and induction. And the various things that make energy are being synthesized by delaying the cause and effect reactions or advancing them and separating from each other. It's very theoretical and hard to explain, but this basically is how this stuff works. This is, if you're going to do it in an engine, if you're going to do it in a motor, if you're going to do it in a static electrical system with coils and capacitors, it has to be done in this fashion. This is basically how you synthesize energy. Okay, go back. So this is like going from a power consumption to a point of power balance, and then our energy consumption, and then into energy creation. So this is where these machines will either consume energy or they will produce energy, and the law of conservation of energy has to be redefined in this situation, because it appears to be that energy is either vanishing or being created, which requires a new way of trying to describe this to keep it into what Heaviside called the law of continuity of energy. Okay, let's keep going. So you basically have to develop a more complex type of mathematical operator. So this basically is the operator we've been using all along. Is we have a type of logarithm to a base raised to a power, which is symbolized by 1 to the 1 over nth power. N being how many poles do you want to describe in an electrical system, whether it be 4 or 8 or 16 or 32. But conventional mathematics will only work with the even numbers, unfortunately. If you try to use odd numbers, like in three-phase or any of that type of stuff, then all of a sudden all trigonometry fails, and a new type of math and a new type of logarithm has to be developed. This is something I haven't finished yet. So we go back into our basic, let's just go back to skip over most of this. These are our basic expressions we use, which now we're trying to advance out in a more generalized form. Let's keep going. So we're expressing, go back. So we're expressing now, we have frequencies where we're no longer going to express these frequencies simply circular, a real frequency in cycles per second anymore, but now we're dealing with these spirals and impulses. So now we have to have another type of frequency, which is called an imaginary frequency. And we use our operator, again, our so-called imaginary operator, to combine these two frequencies. So now instead of having, we have a complex frequency now. Instead of cycles per second, the frequency is expressed in decibel cycles per second, or in trigonometric terms as Nieper radians per second. Because in mathematical calculations, it's always radians per second and not cycles, because that way it works out in the exponential equations. And this is called Niepers. So if I have a 1 farad capacitor and I discharge it into a 1 ohm resistor in 1 second, the amount of energy in the capacitor will drop to 1 Nipper lower than it was originally. So what it is a non-cyclic variation in time, where radians are a cyclic variation in time, and the composite of these is what produces the 8 waveforms we see. Because this one can equal 0, or that one can equal 0, or they can combine in the same way that we were combining the reactances and resistances. Now we can actually work the frequencies, so we're starting to develop now more complex differential equations in order to penetrate these extremely difficult electrical situations, which I just showed you, which are basically unexplainable. But let's keep going. So we're getting into our power relations, so let's just keep going. We get to the final deal here, because this is, okay, so this basically is an alternating electric wave. This is 1/2 of the sine wave, and this is a aperiodic electrical impulse. So this wave is moving in radians per second endlessly. This wave is moving in meters per second and tends to go on indefinitely also, but it doesn't cycle. It just keeps getting 1/2 of a half, 1/2 of a half until there's nothing left. So this is called an alternating electric wave, and this is called an impulsive electric wave. So these are the waves that Tesla was using in his research, and they produce a different type of effect. Okay, let's get, now the important thing is, go back. The important thing is the peak of the impulse is exactly 1/8 of a cycle behind the peak of the sine wave, which shows us our 8-pole relationship that I was going back to in the beginning. So basically, normally the Steinmetz method, you have one operator for every quadrant of motion. But now, in order to explain these more complicated names, we have to have one operator for every half quadrant, for 45 degrees of motion. That's start to see these electrical waves flowing in the system the same way that Steinmetz did when he developed the light second as a way to measure power lines. So if you had a 100-mile long power line, then you measure that line, it's going to be a fraction, but that's why you have powers of 10. You measure the length of that line and how far light goes in 1 second. So if the light goes that far in 1 microsecond, then that's 1/millionth of a light second, and your power line is 1/millionth of a light second long. But if you use your powers of 10, then you don't have to worry about the decimals, and you can still calculate it. So it doesn't matter if it's very short with respect to light. You might say it'd be better to use the light microsecond. And when Steinmetz did this, he found there was a whole other class of waves flowing in the power line that was exchanging energy between the various sections of the power lines and the transformers, and that's where these transients were coming from. Is one power line was dumping its energy into another power line, which then was dumping its energy in another power line. When the waves came through the system, some power lines would deliver energy, but other sections of power lines would absorb energy, and then the transformers would deliver more energy, and it produced these very complex waveforms that up until Steinmetz's time there was no theoretical explanation for. But when the Manhattan Railway project or railway disaster occurred, then it had to be analyzed. They didn't want to play with this anymore. There had been too many fires and explosions, and the public was not interested in playing games with this stuff anymore. So Steinmetz spent 2 years and wrote about a 600 and some odd page book developing these concepts, but he never carried it into the symbolic operators. He just didn't have the time to do it, and he died fairly young, I think at the age of around 50. Okay, let's keep going. Okay, now it's never been developed as a mathematics of symbolic form for space, and Heaviside and Steinmetz all felt it was impossible because algebra is basically a mathematics of time. When you try to take algebra into space, it's normally done with the Maxwell Heaviside equations, which are really useless for electrical engineering purposes. So we have, in order to describe Tesla's electricity, which basically moves at right angles to conventional electricity, we have to come up with a system of space operators that work in a fashion in the way that the time operators did. And as far as I know, I'm the only one that's ever been able to figure this out by working out of the pieces of the people that carried it almost all the way, and they died or lost interest or whatever happened. It's just somehow there was the mind blocks in these early people. They could take it so far, but they just couldn't see the final step. Like in Steinmetz's case, he was harassed by Pupin and all the rest of them to take the minus sign out of his inductance equations and replace it with a positive. In the process, it folded the two waves over each other, and it wouldn't convert to energy, and you had to use non-algebraic means to do it. It was that simple. It was just the minus sign and the plus sign being interchanged, and that was enough. But the mind block was there, but you only can take it so far. All of these people could only take it so far. But the experimenters like Tesla and Thomson were less interested in that, and they just fooled around and used their ideas and created things that worked, but it took Steinmetz and Heaviside to say why it worked and how to calculate it. That was not Tesla's world. Tesla just envisioned the stuff and could build it out of his head. Without Steinmetz, we would have no Tesla. So let's keep going. We'll show this graph. This basically is our generalized flow of electricity. In this case, a more general transmission structure where the power line only has 2 wires. This represents the inside of a transformer coil, which has thousands of wires. As soon as you get into that situation, the electrical field becomes so complex that no one has ever been able to solve it because no one's been ever able to develop a symbolic algebra for it. This is the symbolic algebra. Let's keep going. So we take that element and we put them in tandem. This represents a transformer winding, where this is the wire at the phase lead, and this is the wire at the neutral lead. Yes, this is how energy flows in the transformer. It is a very complex relationship, and now it's not just a simple A plus JB. Now we have what are called 2 degrees of freedom of propagation instead of 1, and that gives us a 4th order differential equation, which normally can't be described in a spatial reality. But as we saw in the beginning, we had centimeters to the 4th power. Obviously, those dimensions do exist. There is a 4-dimensional, in physics terms, type of spatial relationship in electricity, rather than 3-dimensional. It's not 4-dimensional in space-time, it's 4-dimensional in space. In physics terms, the dimensions. In my terms, it's only 1 dimension, it's in space. We express it as 1 dimension in space because we're using the number 1 to describe all of our process. Let's keep going. So basically, if we take 2 windings on the transformer, we take 2 turns. This stuff's usually wound with square material so that the space in between is not left void for leakage magnetisms and stuff to swirl around it. So basically, it's bars of copper. So we have a planes here. So we use our same type of mathematics that we use in alternating current. In this case, this is an electromagnetic wave. So the energy is like flowing down the 2 wires, and these are our basic magnetic forces type of situation. So this vector would represent electromagnetic flow, but we have another vector now which represents a different type of flow. We have 2 magnetic fields. We have the magnetic field that's trapped between the wires in the earlier diagrams, but now we have another magnetic field that surrounds the wires. So we have 2 magnetic energy storages, and in space, they resolve into a situation where there is a net resultant magnetic force. But it might, like with the alternating current, it might not necessarily be representable as a plane figure, but we're using that now just as a calculating model. So let's go on to the next one. Keep going. Keep on to the other picture. Okay, now this is the electrostatic field rather than the magnetic field. So now we have the electrostatic field whose radial lines stand between the conducting materials. And then we have the one, this would be the one of attraction, but this would be like the one of repulsion, where the lines are going out to other conductors in the system. So now we have 2 electrostatic fields and 2 forms of energy storage, and we have a resultant in space of the direction of this field. Okay, let's keep going. So we're starting to explain this now. This was Q, our total electrification, okay, which we know is a product of 2 inductions. So let's keep going with that and see how we can apply that to space. Okay, so we've gone through all this. We know these relationships. Okay, so we can represent one of them, one quantity, as the electromagnetic quantity, which would be the sine of that angle. Let's keep going. Okay, so we have like an axis here. Okay, we have the dielectric field and the magnetic field, and these are where the 2 lines cross, as we see in the circle diagrams around the conductors. We've blown this up now into an elemental space, which is so small that the lines appear straight. And these are the actual lines themselves, the little ether particles all lined up. Where these cross, in terms of quantum physics, these are what are called photons. Okay, and they have specific sizes. and they represent Q, the quantity of electricity dimensionally. So these photons are the electricity, and they're basically in physics, they're energy multiplied by time, they're not energy. And we saw that if we take the rate of change of the electrification Q, this growth or decay, that represents the energy. So energy can go back to or come out of the electrification without defying the law of conservation of energy, or law of continuity of energy. It may defy the law of conservation of energy, but not the law of continuity of energy. So we're expressing these things the same way we did with the other operators, but now we're in space, we're stuck to a different set of constraints. Okay, keep going. So we're going to define these as our basis axes, okay, where we have one axis, and then we use an operator to define the other, not the axes, but the directions, and these are revolving around the axes. So we're trying to utilize this process. There's no way I can really explain it. I'll just show this all as a demonstration. So each one of these things, we're talking about 10 or 15 talks in here. But I'm just trying to give an overview of electrical theory and science and how it works. So let's keep going. So again, we're familiar with how this process works. So we have a quantity of electricity Q. This means that it has a direction in space. So we have one quantity, which we'll call the non-electromagnetic quantity, or the Tesla quantity. And then we have the other quantity, which we call the electromagnetic quantity, which is called the Poynting vector, after another scientist whose name was Poynting. Good name if you're into vectors. So keep going. Okay, now energy by physicists is described as mass times velocity squared. Okay, but we don't have mass in electrical equations, but in order to go into physics, then we'll use this as our reference point to bring it to an area where people with physics knowledge can maneuver into these equations using their systems dimensions rather than electrical engineer systems dimensions. So basically, if I have a magnetic field, okay, the electric current associated with that magnetic field, the magnetic force, in other words, the magnetic force producing or related to the magnetic field, if I take that and compare it to the amount of energy in the system, then I have this basic simple, like the pressure, temperature, volume relationship that gives me the relations between magnetic force, magnetic induction, and energy. And then we can start to develop other types of relationships to maneuver in these things to get our dimensions, but this is beyond the scope of the talk right now. So we have, again, these are basic things. We know that we vary the dielectric with respect to time, that gives us the magnetic force. These are our normal energy relationships, so we continue to move around. Let's keep going. Okay, now what it is the Planck is a integral value quantity because the lines of force have definite dimensions. So every two lines of force that cross to produce a photon, being that the lines have size and a finite relationship where they cross, I believe it was found out by Max Planck, I believe, that the amount of flux density can only increase in unit steps, and these are the size of the steps. This basically gives us the size of the electric, magnetic, and dielectric lines of force, and the photons exist in these discrete units because we're dealing with discrete lines of electric force. It's not a continuous medium. These lines of force actually exist as space-definite quantities. In other words, it's here, but it's not here. Okay, so these are more the trigonometric relations. So in Tesla technology, the magnetic lines of force and the dielectric lines of force work in space conjunction. In other words, there are no right angle relationships and there's no photons. There's non-electromagnetic, therefore there's no velocity. Okay, let's keep going. So this is how we maneuver around. Just beyond this right now. I just want to get to the opposite relationship. Oh, go back. That was right. Go back. Okay, so this would be, so I don't know now. I might have missed something here. It doesn't work. We lost a few pictures, so. At any rate, if we have these lines at all right angles to each other, then that's our standard electromagnetic wave. In other words, if the magnetic lines, the dielectric lines, and the movement of the photons or electromagnetism are all in quadrature to each other, that is our standard electromagnetic wave, like the one that flows down the power line. But the other one of conjunct waves is more of the type that flows through the windings of the transformers. because there has to be two types of flows in the transformers, the ones that go in between the windings and the ones that go across the windings. And the total flow in the transformer has to be the complex addition to reversal operator of the two. Then you get the total electrification. Now, physics tells us that the other component doesn't exist. That's why there was the explosion at the shipyard. Okay, let's keep going. So this is the movement inside the transformer. This is the primary winding, okay, which we'll just say is 12,000 volts. And this is the secondary winding, which is 120 volts. So the metal is broken up fine on one side and coarse on the other. In this case, it would be 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2. So it's a 4-to-1 transformer. So this would be a 440 to 110 volt transformer. So we have the flow of electrons, which represent the resistance, dragging along with the wave, heating up. And then we have the flow of energy, okay, which normally goes between the wires, which is electromagnetic. Okay, so the electron flux moves along with the energy flux of electromagnetism, but we also have mutual induction and mutual capacity that carries energy from this system of conductors to this system of conductors, and those lines of force are all conjunct. So the Tesla energy flux flows this way from primary to secondary, and the electromagnetic flux flows this way in between the wires. In the transformer, the electromagnetic flux is parasitic and represents useless energy flow, and you do everything you can to eliminate it. You strictly want what's called the mutual flux. You don't want the self-flux. This is what Tesla worked with in his transformers. So let's keep going. These are again, our reversal operators. So this is our, go back to the circle. So this is our basic movement through the cycles, so that we can get the net sum, just like we did in the alternating current, how much Tesla waves and how much electromagnetic waves result in the total electric flow in the system. Keep going. So these are moving through all our various formations, which is beyond the scope of the talk right now. So this represents the dielectric equation, the other one represents the magnetic equation, which are oppositely directed, and this, go back to that other one we just had.
Oh, this one?
Yeah. So this is the entire situation. So we have the electromagnetic waves, we have ones that rotate, what you might call vertically polarized, you have another one which is horizontally polarized, then you have the Tesla waves, which move at right angles to that, which have no polarization because they're longitudinal, and then you have a scalar product which cannot be defined in the dimension that takes it out of it, like the weighted point in the resistance reactance diagram. So basically, I just symbolize it as an expansive or contractive, or what you might say a non-zero divergence of energy in the system. So this would be where energy would come out or energy would go away. But this is still very experimental. This is like Heaviside math. So it's subject to criticism and subject to experiment and further work. But this is the basis in which to develop the sun.
When you talk about energy coming out or going in, is it kind of like a sphere moving through a plane? If you think of the sphere as the energy?
No, it's not like that at all.
Okay.
Let's keep going. Okay, so these are all our multiplication tables. Keep going. We want to get more into the practical stuff now. Let's keep going. So these are our we call this circularly polarized electromagnetic waves. One is clockwise polarization, the other one is counterclockwise polarization. Keep going. These are all longitudinal waves. Okay, either a longitudinal wave going one way or a longitudinal wave going the other way. And then we have our scalars. Don't go away so fast. We have our scalars. So we can represent this if we have a piece of rebar stretched between here and the door, and I hit the rebar sideways, transversely, it will produce waves, transverse waves, like electromagnetic waves, which will move at right angles to the direction of energy flow. That's the electromagnetic wave. But if I take the rebar and I hit it this way, the wave ends up there almost instantaneously and you can't see anything move. That's the Tesla wave. These are the two types of waves we're dealing with, and this is the mathematics for describing it using the Steinmetz method. Okay, keep going. So back to tables, we don't need those. Let's just keep going. I think we're done. We're done. Okay, yeah, that's just how the transformer lines look. Let's keep going. That's more multiplication tables. Okay, these are special cases. All this is very important, but I don't have time for it. We're already at 5 o'clock. Keep going.
You
Okay.
can go longer if you want.
Okay, this is how long everyone wants to put up with it. Okay, now this is the workings inside the transformer windings. Okay. Let's go ahead to the transformer. I think it's up ahead here, ways, isn't it? No, it's too difficult. Go back. As soon as I hear it on, I know we can't. Okay, go back. Go back, all the way back. Okay, so,
Oops.
no, this diagram. Okay, so if I take 3 windings out of the thousands that are in the transformers, okay, there's flux lines. Okay, in this case, as we know, the magnetism surrounds the metal, and the dielectricity terminates on the metal's molecular dimensions in between. These cross at right angles, in this case. So we can represent this as a basic electromagnetic condition, which represents the flow of energy at right angles to these lines into or out of the paper. That's the electromagnetic power flow in the transformer. Let's go to the next one. Okay, this is the actual lining up of the flux lines. This is how they actually look in space to a certain degree. And where they cross, that creates the photon flux, which represents the energy flux moving down in space between the wires. Let's keep going. That's basically how it moves. Okay, keep going. So what we're looking at here is this is the windings of the transformer, okay? And we're looking at these 3 terms. So we're starting to work into this is a Tesla coil, let's say. These are the dynamics inside the Tesla coil, which is not operating as a normal transformer because it's compounding these waves now instead of just isolating out specific ones. Okay, I came up with the engineering math in order to calculate this for any simple solenoid to make it operate in the Tesla mode. These are not abstract, these are basic formulas for people to sit down and measure the length of the coil in inches and find out the frequency of the beams. So just run through all these real quick. Okay, now this is the longitudinal wave. Okay, now the mutual magnetism surrounding the windings, okay, and the dielectric flux between the windings is now moving in the same direction. This is how we're starting to get the Tesla wave rather than the electromagnetic wave. Keep going. So now our flux patterns are combining. Let's keep, I think we've got them all backwards here. One more. Okay, one picture is not in here. Go back, go back. So I have to take my word for it. Keep going back.
Back?
Keep going back. We always want pictures. We don't want anything else other than pictures. Okay, yeah, we have the flux lines. Okay, so go to the next one. You got it all. So the basic energy now is not in photons, but is in these longitudinal forces moving between the 2 conductors in the direction carrying from one conductor to the other, where the electromagnetism is at 90 degrees displaced. In other words, one versor rotation in the other direction. So we have our 2 versor components, hence the A plus JB. Reality can still be applied to this, but in a somewhat more complicated fashion for space, because we're dealing more with multiplication than we are addition. Okay, keep going. So the energy now can't be blocked by metal, so to speak, anymore. And these longitudinal waves, that's what carries the energy from the primary to the secondary of the transformer, even though the physicists say these waves don't exist. If you do it the way the physicist says, you have the explosion at the shipyard. Okay, let's keep going. These are all the formula for making your own Tesla coils. We don't need any of that. Keep going. So this is basically how the resultant energy moves around the Tesla coil. Okay, we have energy flow A, and we have energy flow B multiplied by operator K that says we've gone from longitudinal to transverse. And if we take our resultant, then that means that the flow of power around the coil will spiral, and therefore the velocity of light will no longer give us the right results because we're no longer flowing in between the wires, but now we have a composite flow. So that way, it appears that the velocity of light is being exceeded in designing the system. Even Tesla wasn't fully hip to this because he had so much goop around his coils. It pulled the frequency down and made it appear, but in his Colorado Spring notes, you finally see that he was getting frequencies of oscillation higher than we would calculate by saying the energy moves around the coil with velocity of light. But he never mentioned it, but it's in his equation. These are all standard formulas. Standard formulas. Standard formulas. Okay, keep going. So this is the actual transformer winding. So you can see all these little squares in here. Now substation transformers are wound with stacks of pancake or Tesla coils to minimize the voltage gradients and to keep the mutual induction going. So each one of these is what's called a pancake coil, and they're stacked in series. Okay, now the first attempt to analyze these waves in Steinmetz's time resulted in complete blockage because the differential equations were too difficult to solve. And as Steinmetz said just before the explosion at the shipyard, that the Maxwell model